Hey guys, we're back today to make a little bit of benzoic acid. I want to make it because it's a precursor to something called denatonium benzoate. Denatonium benzoate is often referred to as the most bitter compound known to man, and to me this is interesting and I want to make it. After I made the benzoic acid in this video, I actually did proceed on to make the denatonium benzoate, and that will be posted in a future video. Anyway, besides making denatonium benzoate, it does have several other uses chemistry-wise. I'm not so much interested in a lot of the other uses it has, but I want to use it to make something called benzoyl chloride. The benzoyl chloride can then in turn be used to make something called benzoyl peroxide. Some of you might recognize the name, and this is because benzoyl peroxide is used in a lot of acne creams. It can be also used to bleach teeth and make them whiter, and I think this is just kinda cool. I'm not actually going to use it, but I think it might be cool to make. Anyway, now to address what we're doing in this video. We're going to be regenerating sodium benzoate back to its acidic form, benzoic acid. To do this, we can use almost any acid, but the easiest one to use is just hydrochloric acid. Sodium benzoate is a very common and cheap food preservative, and it can be pretty easily purchased online. Anyway, with that being said, we can now dive into the synthesis. You can see here the two reagents that I used for this experiment. On the left, you can see I have the sodium benzoate, and on the right, I have my hydrochloric acid. In total, I used 60 grams of sodium benzoate and 50 milliliters of the hydrochloric acid. So to start off, 60 grams of sodium benzoate is weighed out and placed into a beaker. I then poured in 300 milliliters of distilled water. The sodium benzoate is then mixed into the water until it fully dissolves. It doesn't mix by magic, and there's actually a spinning magnet in the hot plate below. I didn't show it, but inside the beaker there's a magnetic stir bar which spins along with the magnet in the plate. After mixing for a little while, it should become a totally clear solution and all of the sodium benzoate should be dissolved. I then added 50 milliliters of my 31.45% hydrochloric acid. The moment the hydrochloric acid hits the water, a white precipitate falls out. This white precipitate is our benzoic acid, which isn't very soluble in water. So what's happening here is the sodium benzoate is reacting with the hydrochloric acid to form benzoic acid and sodium chloride. The benzoic acid isn't very soluble in water, so it precipitates out, but the sodium chloride is very soluble, so it stays dissolved. We're also using an excess of hydrochloric acid to make sure that all of the sodium benzoate gets converted. I slowly add all of the hydrochloric acid, and then I use a glass stir rod to mix things up. The magnetic stir bar isn't used here because the precipitate is too thick for it to stir properly. To try to make it so it's not as thick, I add an arbitrary amount of distilled water. I again use the glass stir rod to mix it around, and then I let it sit for a few minutes just to make sure that all of the sodium benzoate has reacted with the hydrochloric acid. The next thing that I do is I set up a vacuum filtration, and I start pulling off all of the liquid. In theory, this could also be done using a gravity filtration, but it would take a lot longer. You can see here that it only takes a few moments to pull almost all of the water out. After I've pulled most of the water out, I top off the filter again. I do this a few times until all of the sodium benzoate has been added, and then I use a glass stir rod to mix things up a little. I do a couple water washings by pouring a little bit of distilled water in and then mixing it around. By doing this, we try to wash away a little bit of the hydrochloric acid and sodium chloride that might be left behind. After a few washings, I pull vacuum on it for a little while to try to dry it up. By pulling air through it, we can get a lot of the water out, but it's still never going to be fully dry. Once I thought it was dry enough, I transferred it to a large watch glass. You can see here that we have quite a lot of nice white benzoic acid, but unfortunately, it's not super pure. I transferred as much as I could from the filter flask, but inevitably some would remain stuck and left behind. So this was the final yield of the crude benzoic acid, but like I said before, it wasn't super pure. I think it's because the sodium benzoate that I used wasn't really great quality. Anyway, I was in a rush, so I ended up using this in my synthesis of the denatonium benzoate, and it worked out, but it might have messed things up a little bit. I could tell very easily it wasn't super pure because it kind of had a little bit of a weird smell to it. Anyway, when I had a little bit more time, I decided to clean it up by carrying out a recrystallization. To do this, all of the crude benzoic acid was added to about 800 milliliters of distilled water. Then, with strong stirring and a hot plate below, I start to heat it up. Our goal is to heat the water up to its boiling point and dissolve all of the benzoic acid into solution. As the solution heats up, more and more benzoic acid will dissolve, but we still will probably need to add a bit more water. So basically, anytime the water reaches its boiling point, but there's still undissolved benzoic acid, we need to add more water. As we do this, the amount of solid benzoic acid that's floating around slowly decreases. I place the watch glass on top just to limit how much water is lost as it boils. Eventually, we'll reach a point where it looks like pretty much all of the benzoic acid is dissolved. When this happens, we take it off heat and we allow it to cool slowly to room temperature. As it cools, some very nice crystals should start to form. After a while, we get a lot of crystals falling and it kind of looks like it's snowing. Eventually, enough crystals form that it slowly takes over the beaker. Here we have a zoomed up shot of the needle-like benzoic acid crystals. After it's fully cooled to room temperature, it's completely taken over by crystals. To precipitate as many as possible, it's then placed into a freezer. Once it's been thoroughly cooled, it's taken out of the freezer, and using a spatula, I mix up the solution. Then, just like before, I use a vacuum filter to separate the crystals from the solution. Because I have such a large volume of water, I have to fill the filter several times. The beaker is washed a few times with distilled water to get out as many crystals as possible, and also to wash the crystals in the filter. Each time the water is added, the vacuum is pulled and we remove as much water as possible. All of the impurities that we've extracted from our product should be in the solution, so we really want to make sure that none of this is left behind on the crystals. Anyway, after a few washings, I pull a vacuum on it for a little while to dry it up as much as possible. After this is done, I turn the filter upside down and I pour the crystals out onto a piece of paper. The crystals came out as a solid chunk, so I use my spatula to spread them around on the paper. The paper that I'm using is just plain old printer paper, and below it is some paper towel. The next step is to leave the crystals out to dry, and the paper towel below really helps to do this. After leaving it out for a day, we're left with some very nice, fluffy benzoic acid crystals. This stuff doesn't have the weird smell that it did before, so I know I've at least cleaned out that impurity. All of the benzoic acid is then poured into a jar for storage. I honestly think I forgot to weigh the benzoic acid, so I don't know exactly how much I got. I've also used some of it since I've filmed this video, so I can't just go back out and reweigh it. In general though, this reaction should be near quantitative, meaning that we should get almost 100% yield. Some benzoic acid is probably lost during the recrystallization, so I imagine the yield is probably hovering around 95%. Anyway, that's it for now, and I hope you guys enjoyed it. In the near future, I will be posting my video on the synthesis of denatonium benzoate, and I will also be making the benzoyl peroxide and the benzoyl chloride at some point. Also, for a little bit of guidance on this video, I watched the video made by Doug over at Doug's Lab. He has a lot of good videos, and if you're into chemistry, I really suggest checking him out. In the meantime, before I release my next video, you can check out my new channel that I made, which is very creatively called Nile Blue. This channel is going to be more focused on general science, so you'll see videos here like the one I posted on why water puts out fire. Right now I only have one video, and it explores the pseudoscience of alkaline water and an alkaline diet. I'll provide a link below in the description if you want to check it out. Also, for those of you wondering, the next video that I'm going to be posting is the final part of my luminol synthesis. Anyway, that's all I really have to say for now, and I'll see you guys on the next one.